I've been doing this for a while, and I haven't seen a whole lot of other people do it, and it's pretty simple to do with a basic diagram. So I think this is one of those things that's highly underutilized because a lot of people want lights on their RC cars, obviously. And with how cheap LEDs are and everything, it almost makes no sense to not do it. If you're already spending so much money on these things to do so much, the lights I think add so much to it. But the thing is, a lot of people are on a super budget and they don't have 4, 5, 6 channel spectrum controllers and everything to control all these added features. But you still want automatic lights are still cool. When it's dark, you want lights. When it's light out, they can be off, whatever. Or maybe just have your parking lights on when in the daytime. When it gets dark enough, turn on your headlights. If you have a 2-channel or RTR, or you're lucky enough to get an RTR with a 3rd channel and you're already using it for a winch or whatever, it's nice to be able to have the lights turn on and off. But it can be done relatively simply with very inexpensive components to have automatic turn on lights when it's dark, just like most modern cars have a position on the headlight switch to just put it in automatic mode. So that's basically what I've done here, and if you can see, I've left some circuit board left. I'm going to cut off when I'm done, and I've done this a lot of times. It works really well. I haven't had any problems, and it's in working mode now to where show you. Basically, here's a light sensor, and I put this on a cord so you can place it like in a window or something on the RC car, so it can pick up basic ambient light from outside to decide how bright it is. And this thing is, smaller than most LEDs. They're super cheap. You can buy 100 of them for a couple bucks off of eBay, and I just solder them on to bolt cable, so you can place it wherever. There's a little voltage comparator chip, and I'll post a diagram for this probably on part 2, so you get an idea of what actually I'm using to do this. But basically, this is a chip that compares 2 different voltages, and I'm using this sensor along with a resistor basically makes a voltage signal depending on the brightness or darkness level outside. And then I use the potentiometer as the set point, which also you can turn up or down to set a voltage level, which is the trigger point for whether or not this chip outputs the signal to turn whatever you want on. In this case, obviously LED lighting. So what you do is when you set this whole thing up, you set it up and find out at what darkness level you want your lights to turn on, and you can measure the voltage on one of the pins when this is all set up. And like I said, in part 2 I'll get a little bit more in depth with where to measure the voltage to do that. And honestly, a lot of times I will just set up the whole setup and set the thing outside, and right when I feel like it's dark enough to where I want the lights to be on, I will measure that voltage, and then I set the potentiometer to that voltage, and it will turn on. And then, like I mentioned earlier, the circuit already works, and I can show you right now. Here's a test LED on it, set up on the output, just for demonstration purposes and setting purposes, so you can verify everything's working. So when it goes dark, when the sensor, right now the sensor is getting light from the ceiling, so it thinks it's daylight out, and no problem right there. But when it gets dark, and there's no light getting to the sensor, the output goes on. So that will turn on the output of that chip to turn on these lights. And you can't. This chip, I believe, only has an output of like 20 milliamps. So you're not gonna hook it up to a whole array of LED lights. But you can hook it up to a basic small transistor that you can also buy 100 of for pennies off of eBay, and then you can just turn on as many LEDs as you can imagine. It works really well, but the only thing I'm going to add to this is what I have done in the past is hook this output up to a timer chip. So the output turns on, it'll turn on the output for a minimum of 10 to 20 to whatever seconds. So as you're driving your RC car through an area where maybe there's like kind of a shadowy area where you're driving under trees or whatever, your headlights don't start flickering in your car and make your car look like it's gone mentally retarded. I put the timer on it, so once it gets at least a trigger, the lights will be on for at least 20 seconds. So as long as you've gotten in the trigger zone of it's starting to get dark and it starts to get just a little bit darker, the lights will turn on. But you don't want the lights flickering on and off in your car as you're driving through an area. It'll look stupid. So what I've done in the past is done a timer chip, which is another chip about the same size as this one, which requires a bunch of other setup work with capacitors and this and that. But I'm going to try something a little bit different this time, and I'm going to try the output off of this chip onto a capacitor, so it charges the capacitor, and then it'll drive the transistor. So the idea is that it'll charge up the capacitor, and then the capacitor will slowly drain down if the chip goes back into another area where the lights won't be on. It'll slowly drain down, and then not make the transistor flicker on and off needlessly, and I think that'll be a lot simpler. So I'm going to try that and see how that works. Actually, I'm 90% positive it's going to work perfectly. I'll cover that in part 2. But this is just to give people an idea of you don't have to have a third channel to have on and off lights. Like it's literally, this is me just covering the light sensor. It's automatic. It's awesome. This is super compact, and you don't need this entire length of the circuit board. Right now I'm only using up to this point right here. And if you want to make this thing, once you get it set to a point that you're happy with, you can, honestly, the best way I've found is to take styrene, little styrene plastic pieces, encase this thing, glue it together, and then just cover and then after it's dried and it's sealed basically with the styrene, cover the entire thing with hot glue, and then once that's cooled down, either hot glue it into the car and hide it in a tiny little spot or whatever, and you can dunk this thing all day long. It's as waterproof as can be. And this thing, the little light sensor, I haven't had any water. They're basically almost encased in some type of plastic themselves to begin with, so I haven't had any water issues there either. But I also don't drive my vehicles underwater. But a little bit of hot glue around here, around the area where there's any electrical connections, and you'd be fine. I'd try and keep it off the surface to not screw with the sensitivity of the sensor. But yeah, I'm gonna make a very detailed diagram of how to do this, and hopefully and I've already made the diagram to do it with the timer chip, but I think that's a little bit overcomplicated, and it doesn't need to be, and it works amazing, but I don't think it needs to be done that way. And I think with just a basic capacitor and a transistor, I think that will cover that part of the circuit the exact same way. With it'll literally reduce the entire project to about 60% of what's needed to do it the previous way I've been doing it. So yeah, I mean, super awesome. I mean, something modern cars have, and you can literally, if you buy enough basic electronic components to do a lot of the stuff for your RC car fleet, this entire project probably cost me 50 cents in parts. So I don't know, it's kind of neat, and it's something different. You see the same stuff every day, day in and day out, and it's awesome. And a lot of guys get really into certain stuff that's they got money to do stuff that you can't do. But a lot of times you show up to the trail with an RTR Red Cat Racing $200 truck with a couple features like this, and you're gonna blow people's minds that are driving around $800,000 trucks. Is what it is. I'll get into in part 2. I'll get into a little bit more detail, and before I film part 2, I will have finished the capacitor and transistor part of the circuit for the output to see how well that works, and I will. I'm going to try and figure out how to post an actual diagram, and I do this a lot, and I make really detailed wiring diagrams on how to do these projects, and I will start figuring out how to post them either in the video so you can see, at least screenshot them, or see if I can figure out how to post them in the the video details section. So I don't know if you're interested in this or have any questions. I'd be happy to answer any questions. I've done this on many cars, many RC cars and many full-size cars. Works great, super reliable. Once it's built, and you do it right, and you actually, and I like to use hot glue. Hot glue the wires, any of the parts that wiggle in the in your circuit that seem fragile. Put hot glue over them, but don't get crazy with it, because some circuits are super sensitive, and you put too much hot glue on them, you'll actually get some conductivity through the hot glue, and then you'll sort of it sort of messes up your circuit, because you start getting cross communications on your wiring that weren't meant to be, because some of these chips they're super sensitive to input, so you can mess stuff up. So I think it's really good to kind of build a little styrene case out of just styrene sheet. Just cut 6 pieces that'll kind of make a little box around it. Seal it up with CA glue, and make sure you kind of CA glue the thing in there so it's secure. Hot glue the wires where they come out of the thing, but when you're done, just give all the seams of the styrene a little seam of hot glue, and put that thing anywhere, and you'll have this thing underwater all day long, and you'll literally never have a problem with it. But like I said, how awesome is that? You go in dark, all of a sudden your lights turn on. And you don't have to, I like the idea of maybe leaving your parking lights on full time and wiring this setup just to your headlights. So just, when it's daytime you're driving, because it's still neat to have lights on all the time anyway. But when it gets dark, you have maybe your LED light bar in your headlights or whatever. When it gets really dark and you actually need lights, that's when you can have your lights come on. It's another idea, but. So part 2, I'll have gone a little bit further with this. I'm still going to try and keep the super compact. So I'm going to try and keep the capacitor and the transistor probably right in this little open area of the circuit board, and then try and cut this thing off about right here to keep this thing super compact. And then I'm either going to install this in my either Red Cat Racing Gen 7 or my RC 4-wheel drive Jalonde 2 Cruiser. I don't know. We'll see where it goes. I'll cover all that in part 2. I just wanted to throw this up there for right now. And let me know if you have any questions. Thanks.